Hello. This is some of the equipment in the electronics lab. This bottom one is the voltage source. It's got an on-off switch, and you can select the values you want. You would use a cable like these to go between this and say your breadboard. And this one has an alligator clip on one end, and you can make the alligator clip work as well. We want this one to output a voltage, so you want to make sure it's out. This button is out. If you push it in, it's trying to source current. If you leave it out, it's sourcing voltage. And so then you can then turn the coarse and the fine to set whatever voltage level you want. When you get done, always go down to 0, make sure it's on voltage, turn it off. This will get you started. Above it we have a function generator, and we will deal with that when we get into the oscilloscope. But the other meter that you have on your bench, and there are some variations, is a multimeter. And a multimeter has an on-off button. So when it comes on, it has probes that look like this and little pointers on the end. Typically we are going to measure voltage primarily. So I'm putting the one lead in the common, the other lead in the voltage, the one that's got voltage in ohms. And now I've got to make sure it is on ohms, and as you see it says millivolts DC. So there's a button here to push, and if I push it, now you see that it is reading megohms, and it is OL, which means it is over limit. It's reading more than it can. So I've got this set up because I wanted to show you how the breadboard is laid out. And I'm going to turn off the power supply and hopefully get the breadboard here on a better camera angle. Alrighty, you see these sections of 5, and I'm going to put a resistor in each end. On that top row. See those two resistors? Okay, any of the holes between those two resistors are electrically connected, and they are connected to no other place on the board. How do I know this? Well, I've got the experience of knowing it, but if I take my ohm meter and touch my leads, should go down to a very small value. Should go to 0. I'm doing this one-handed basically, so I can't. But on your breadboard, those 5 holes are connected, but they are connected to nothing else. So as you see, you've got a lot of different connections. Now, the 5 over right here are not connected to the 5 over here. So you've got to get used to it, and but all breadboards are pretty much the same. Now if I go over here to these rows of 2, what you see is they are connected as you go up and down. Instead of side to side, they're connected up and down. So if I was to put a resistor in the top hole and the bottom hole, then maybe gravity will help. I see that I've got continuity all the way through. I've got a low ohmic reading, which means from the top all the way down that row to the bottom, I've got continuity. If I move the top one over a notch and I leave the bottom one to the left and I put the top one on the right, I have no continuity. But that whole row all the way down the breadboard that whole column, if you will, all the way down the breadboard is connected, but not to the one beside it. You also see red and blue lines, and those are typically set up to run your power to. So like if you were going to run a voltage into the top, you could take a wire and then jump it to, say, this red, one of the red holes here on this side, and that would bring your power that's coming from your power source to all these. The minus would go to, say, a blue, and you don't have to do it that way. You just got to be consistent, and you've got to set your circuit up the right way. So not only will we be building them with SPICE and simulating them, we also want to teach the skill and you to learn the skill that you can actually build circuits. Now, how do I put resistors in series? How do I put resistors in parallel? So I've got these two resistors, and if I want to put them in series, I can do it as simply as, okay, I think I said series. If I want them in series, I can do them as simply as making a connection between two of my 5s with the resistor and making another connection between the other two of my 5s. So what I see is I've got that's connected. They're in the middle, they're in the same row. So that interconnects the two resistors, and then it goes down to a bottom one. So if I ran a power from my red to the top and a return from my black down to my bottom, I would have a complete circuit. A lot like I did in the LT Spice video, although these resistors are not the right value. Something to notice on the breadboard is as they age, as students build circuits incorrectly, you see the brown, the tan spots, and that's usually a indicator that something got warm. So you stay away from those spots, still got plenty left. You can build your circuit. So that was series. If I want them in parallel, I can just make them in the same 2 sets of 5. So I put that one there, and I put that one there, and then I get in really close. You can see that the top and the bottom are both in the same. Those resistors are in parallel. And I don't necessarily have to go up and down. I can go sideways. As long as I get everything in the same. So I can go sideways to parallel. Again, one grouping of 5 is not connected to the next grouping of 5 beside it. They are electrically isolated. So that is a parallel. It's kind of hard to do resistance sideways like that. You would have to go up and down, or you would have to jump all the way over to the other side. You can use the middle rail. You can power it. Generally speaking, when you build circuits, you want to use as few connecting wires as you can, because it's just less likely that you'll cause a problem. But anyway, that's how the breadboard's laid out. You can feel it, the 5, the gap, the up and down. The ridges are raised, so you can sort of know where you're at, and then each side, and then you can feel the middle. So it's visual, but it's also tactile, so you can feel it. Anyway, that is how you connect resistors. That is how the breadboard's set up, and that's a little bit on the ohm meter. That's generally the connections, volts, ohms, and common. And it's also got to be set right on the ohms. Thanks for watching.